are going to do we are going to do algorithm and flowchart. So this is to supplement what I have already uploaded yesterday, the file on computer fundamentals. So I just wanted to tell a little bit about algorithm and flowchart because I had not explained fully in that file. So this is about problem solving by computer. So how does a computer solve a problem? So this is the question. So how does a computer solve a problem? So this is the question we are asking. Clear? So we'll start with this problem. So in an unassorted sequence of numbers, find the largest number. Means we have to find the largest number from an unassorted sequence of numbers. That means we may be given some numbers like say 100, then 1000, 5, 8, okay, 27, then we may have 1050. So like this is so this is an unassorted sequence. So if you are giving the computer these numbers, so how the computer will find out the largest number? Like from here we can easily tell that 1050 is the largest number. So how will you tell the computer to do the problem? That is the question. So the solution is like this. So any number, so you have a sequence of numbers like this. Okay, so this is the first number, this is the second number, third, fourth, fifth, sixth. So we have a sequence of numbers. So this could be my first number, first input. So 100 is my first input. So how to do it? So take the first number. So take the first number, read it and label it the largest number. That is, we will say, so this is 100. So we will say 100 is the largest number. Then so this is the first step. So second step is repeat steps 3 and 4. So step 2 is telling repeat steps 3 and 4 till we reach the last number. This is typical of a loop. So in a computer program, there is something called a loop. That is, you have to do something repeatedly till a certain condition is not satisfied. So that is called a loop. So you have to enter a loop here. So these steps 3 and 4 are the part of the loop. So what is step 3? Read the next number and compare it with the largest number found till then. Okay. If the next number is greater than the largest number, okay, so my largest number was 100. So if the second number is greater than 100, then make it the largest number. If not, if the second input that we had taken is not the largest number, then keep the largest number unchanged. And so you have to keep doing till you have finished all the numbers. 100, so you have to start with 1000, then 1000 is the next input, then 5, 8, 27, 1050, and once you have exhausted all the numbers, then when the last number has been read, print the largest number. So what do you mean by this? So let us see this thing with the help of a small example. So what is written here? So it's very clear. So here we have an input queue. We have an input queue and my numbers are, I have taken 3 numbers, 35, 45 and 15. So 35 will be my first input, then 45, then 15. So what the computer does is that so what we will do is we will allocate memory box. So what is it is called memory box. So in the computer we will allocate memory to something. We will allocate memory and we'll call that memory here my input, and we will allocate another memory which we will call max underscore num. Okay, so we will allocate 2 memories and call them my input, my underscore input. So we will allocate 2 memories and we will call one my input, my underscore input, and the other one we will call max underscore num. The name itself signifies what I am going to do with this memory. So computer will have memory, so there things will be stored. So when the first input comes, it is stored in my input as 35. Now this box is empty, right? This box is empty. Now what is the second step? Second step is, so the first step was first number, take the first number, read it and label it the largest number. So now it has been read, my input, and now this 35 is been copied to the memory max num. So the value that has entered max num is now 35. Clear? So this has been copied. So that was my first line in this. And now we have to enter a loop. So so you can see here we have to enter a loop. So repeat steps 3 and 4. So now we are going to see what steps 3 and 4 are. So what? Read the next number and compare it with the largest number. So next number is 45. So in the memory my input, now 45 enters. Okay, we have 45. While in this memory which we have defined, which we are calling max num, we have still 35. And then what we are going to test, whether this 45 is greater than 35. So now we are testing a condition being tested. So what is that condition? Whether 45 is greater than 35. If 45 is greater than 35, then this 45 is now copied into the memory max num. So now 35 has been removed, and what we have is the new max num, which is 45, because 45 is greater than 35. So now in my input memory we have 45, and then in max num we have 45. Now again we have to go to the next number. So this is the loop. So first I have to, so this is the loop. So we have done this. If greater than the largest number, make it the largest number. If not, keep the largest number. So read the next number and compare it with the number found. Okay. And then if greater than the largest number, make it the largest number. If not, keep the largest number unchanged. This also, so 3 and 4 we have done here. So this is like, this one was like, yeah, this is, so this part will be 3 and 4. And now what was it? So this one was, now we have to repeat till the last number is reached. So this is the loop. So now we have to see whether there is more input. Yes, we have more input. There is another number is 15. So now in my input 15 goes in, whereas in maximum we have still 45. And then we will repeat steps 3 and 4. Okay, so we will test the condition 15, whether 15 is greater than 45. 15 is not greater than 45. So here nothing changes. So here nothing changes. So here nothing changes. Nothing changes. Okay, so what is this? In my input, so this is my input, this is a memory box which we call my input. We have 15 and this is my maximum. This is my maximum. We have 45. This is the final. This is the final state. This is the final state. Here, this is the final. This is the final state. So 15 and 45, they are final state. And finally, what we are going to print is, we are going to print the largest number. So what we are going to print is 45. We are going to print max now. Clear? So what we did was the logic using which a problem is solved is called algorithm. So this one was algorithm. So what we did here was algorithm. This is the logic we are using. And then there is another term called flowchart. Flowchart is nothing but the algorithm is expressed diagrammatically through a flowchart. And we'll see how to represent the algorithm diagrammatically through a flowchart. So to represent a flowchart, we have to know a few rules. Okay. So one is a rectangle with a rounded corner. So these are the symbols we use when we draw the flowchart. So this is the rectangle with rounded corner. So this is used to indicate start and stop. So this means this. So rectangle with rounded corner means is simply like this. So I'm not good at drawing, but I think you get the point. So this is like rounded corner. This is the rectangle with rounded corner. So this represents start or stop. Then we have parallelogram. So parallelogram represents input or output operation. We'll see what it means. So we know what a parallelogram looks like. So it will look something like this. Okay, this is a parallelogram. And then we have diamond shaped box represents condition being tested. And depending, so exit is taken based on the answer. So this is important. So what it means that this diamond shaped box, when you come across that, it means some condition is being tested. And depending on the condition, which path will be followed, that will be decided. We'll see the example. I think in my file, I have written some exit, some number has to be displayed. That I think is not correct. So that you can just ignore. Okay, so how does the diamond shape look like? Diamond shape will be like this. So in a flowchart, it will come out like this. Okay, so this is your diamond shape. And then there is a rectangle. Rectangle means storage or the arithmetic operation. So this is some kind of logic operation. this is some kind of logic operation, so that will be denoted by a rectangle. So rectangle, and we'll see how to use this rectangle with rounded corner, parallelogram, diamond shape, or the rectangle in implementing this one. So whatever we had written here, the algorithm, I showed the example how the computer works. The computer works using the memory. So whatever you have to write in a memory. So how it operates, we saw an example, and this is what we are going to implement in the flowchart. And this is the flowchart. So what it means? So this is the start. So this is how this progress. So this is a start operation. Okay, here it's the start, and here it is written read my input. So what you have to, so you have to allocate a memory and call it my input. Okay, and the input will go in that, the first input will go in that my input, in that memory box. So that is called read my input. Okay, so that is called read input. That is, the input will go in the memory box. It will be written in that space. So this is read input, my input. So this is, you can see this is a parallelogram. So this is input operation. That's why this is a parallelogram. This is an input operation. And next one is, what it's telling is that so we will allocate two memory spaces. So one is max, like before I had already explained, max underscore num, and one is my input. And now what it's telling that, so this has been allocated. So whatever is there in my input will go to now max num. So this is what is written is max num will take the value of my input. That's what is written here. This is what is written in that box. This one. So this is a rectangle. So this is a storage or logical operation. That's why it's a rectangle. So max num will now take the value of my input. That we have seen this thing. We already have a knowledge of this thing. So this part we have already done this. Here we have, it's copying. Okay, my input goes to max num. So same thing is happening here. So max num takes the value of my input, and then there is this diamond shape. So here there is a condition being tested, and what is that condition? So any more number. So what is written here is any more number in that diamond shape. Any more number. Any more number. Okay, it's asking if there is any more number. If there is no other number, then what it will do, if no is the answer, then it will print whatever max num is there. It's going to print. Okay, and this is, again you can see this is a parallelogram, because this is a output. This is the output. This is what I want finally. Printing. So what we want is output. We have to print max num. Okay. So finally what outcome will be? Print max num. Whatever is written in that memory space max num, that has to be printed. That is the outcome. If no, if there is no other number, then this. If yes, that is where the loop. If yes, then read my input. That is, whatever the next input is, that will be go into my input. Okay, and this is again an input operation. So what we have is a rectangle. And after that, once this input, once the we have updated our input, my input, then we ask the same question. We are asking here. So this is again what we have is a condition being tested, and here what is written here is my input. We have done it. Is my input greater than max num? This is the question that is being asked. If my input is greater than max num. If no, if my input is not greater than max num, okay, then we go back here and ask if there is any more number. Correct? If there is any more number. If there is no other number, then we go along this path. If there is more number, then we take this path. So what we are seeing is that this condition being tested. So this gives us, if there is no number, we will go along this path, and if there is number, then we will repeat the process. And again read the input, and then we will check whether the new input is greater than max num. If yes, if my new input is greater than max num, then what happens? Then our max num, so in the space, memory space max num, we will write whatever is there in my input. My input. So that is what is written here, and so this is a rectangle, because this is again a arithmetic operation or storage operation. So this is not input. So inputs are parallelograms. So this is a arithmetic or storage operation, and after this is done, we have to go to check whether there is any more number. Okay, if there is more number, then we have to again go along this path. Okay, or if there is no other number, we just have to go along this path and print whatever is written in the memory max num. Clear? So final result will be print max num. So this is where the loop is. This is where the loop is. This is the loop. This is the loop. So this part is the loop. This is the loop. So this loop, it will continue. So this is the loop we call in computer programming language a loop. So this loop will continue till input is there. Till input is there. And when there is no more input, then it will just go in this direction, print maximum number, and then the program will stop. So this is the stop operation. So we started with this thing, rectangle with rounded corner, and finally it will stop, rectangle with rounded corner. So this is a flow chart, and I will end here, and if there is any question you can let me know. Thank you.